the results of their harvest. It's a giant leap forward in the race to find the next Earth. Over 1,200 possible planets. If they all can be confirmed, Kepler will single-handedly triple the number of known worlds. Most are monster-sized gas giants, some even bigger than Jupiter. But at least one is about the size of our own Earth.
It just popped right out at us. And so we knew at that moment right away that we were going to be able to see the signal of a really Earth-sized world.
It is a planet that will come to be known as Kepler 10b. It is the smallest world ever discovered outside of our solar system. And it takes the Kepler team one step closer to finding the next Earth. Kepler 10b is not only rocky, it's roughly the same size as our home planet. But does Kepler 10b really exist? Does this mountain of data add up to a planet? Or could it be another mirage like Zarmina's world? Natalie must confirm the finding. She relies on one of the most powerful telescopes ever built. It stands at 14,000 feet on the shoulders of a dormant volcano. Because it is so difficult to access, Natalie, like most astronomers, works remotely with this marvel of technology. Today, she has come to the cold summit of Mauna Kea, Hawaii, to see the Keck telescope in person for the first time.
Oh my God.
Keck veteran Ron Lobb has worked at the observatory for years.
Oh my God. Wow.
Welcome, Natalie,
Hi.
to the Keck telescope and the awe-inspiring 10-meter primary mirror.
Each of Keck's twin telescopes consists of a giant 33-foot mirror. These mirrors are made of 36 hexagonal segments that weigh almost half a ton apiece. Small motors in the back of every segment keep them working together as a single giant mirror. Keck also combines this telescope with a high-powered laser. The laser tracks and removes the distortions in the air that cause the stars to twinkle. This makes Keck one of the most sought-after telescopes in the world, and one of the best places on Earth to confirm a discovery.
We have to compete with other astronomers for time on this telescope. The whole Kepler project only gets 20 nights a year. So we have to be very choosy about the planet candidates that we pick to confirm here.
Natalie shares her data with Ron. The existence of Kepler 10b is confirmed.
Every single dot is marking a transit. There's just a forest of transits here in this data. So these are Kepler 10b. They're so close together because the orbital period is so short.
This means Kepler 10b is extremely close to its sun and blowtorched in the solar heat.
We look at these charts and graphs and we tend to forget about the reality.
Could life as we know it exist on Kepler 10b? Natalie Batalha decides to find out. She joins planetarium director Sean Lotch at the Kilauea lava fields on the Big Island of Hawaii.
You can start to see, of course, this really black
Look how
area.
dark it is.
This flow is only a few years old, which is pretty amazing.
This landscape is similar to the kind of terrain Natalie thinks is on Kepler 10b.
I can see these sparkly flecks in the air here from the sunlight reflecting off of it. I bet that's pretty dangerous to breathe in, huh?
It looks like a rope or like licorice, you know, it's twisted.
I'm scared to know what's underneath here.
Jeez.
Like Zarmina's world, Kepler 10b keeps the same face towards its sun. One side trapped in everlasting day, the other side in eternal night. This lava field is what the night side might look like.
Oh my God, it's getting so hot.
Yeah. This is incredible, and you can see the
Oh my
flowing
gosh.
up there through there
It's
and up from top.
flowing. Oh my gosh, it's so hot. There's our sample of Kepler 10b. Already hard.
If you can take it home in your Ziploc
I
bag.
can't. It's not going to cool off quick enough, huh?
I think so.
I think it would burn a hole in my pocket.
Yeah.
Okay, ready? See if we can cool this rock. Something we don't have on Kepler 10b, right?
Right. A little bit of water.
Conditions on the night side are extreme. Life as we know it could not exist. But nothing on Earth compares to what's on the day side. Passing from night to day, temperatures reach over 2,500 degrees Fahrenheit. Hotter than a blast furnace. The hemisphere is dominated by an ocean of molten lava. Like icebergs, giant chunks of iron-rich rock could be floating near the shore. Streams of lava tumble over numerous lava falls. Kepler 10b may be a rocky planet nearly the same size as Earth. But it is a world hostile to life. And yet thousands more planets are waiting to be explored in the search for the next Earth. Can astronomers actually find it? Or are we alone in the universe? Mars. A world that has tantalized humanity with visions of alien civilizations. But this is not Mars. It's Death Valley. Astronomers Sarah Seeger and Oded Aronson have come to this otherworldly landscape on a search for life.
It's not too hard to imagine that we're actually not here on Mars Hill in Death Valley, but actually in a very similar place on Mars.
It's so similar to Mars, NASA uses it as a test ground.
So a couple of decades ago, there were a group of geologists that were out here looking for sites that would help them calibrate some of the instruments that they were hoping to send someday to Mars. And they said, wow, this looks just like the Viking landing site. And indeed, eventually they came up with a description of the kind of instruments that they would want to send to Mars.
But this isn't the only alien landscape in Death Valley. What conditions are necessary for life?
What really matters is the temperature of the planet's surface.
Life as we know it exists only in a narrow range of temperatures determined by a planet's distance from its star.
This fire represents a star like our sun. It's so excruciatingly hot near the star. It's hot enough to not just melt lead, but even to melt rock.
A planet can also be too far from its star.
Far from the star, it is extremely cold, way too cold for life as we know it.
But what if a planet is in a place where temperatures are just right? Like the children's story Goldilocks and the Three Bears.
Here in the Goldilocks zone, the temperature is not too cold, not too hot, but just right for surface liquid water.
In the end, it's all about water. Finding life and the next Earth depend on it. Our planet has some 367 million trillion gallons of water. And almost everywhere you look, there is life. But here in Death Valley, life can be difficult to find. And in a place as hot and dry as this, it comes as no surprise.
The hottest temperatures ever in North America were recorded here at 134 Fahrenheit. This is one of the most inhospitable places on Earth. It is so hot here, even in winter, that it's almost unbearable. What's weird is that it looks like winter back home. It looks like there's snow on the ground. This is actually an immense plain with water that used to be here that is now evaporated. And what's really weird is it's not snow, it's salt.
Is there any water here in Death Valley, one of the most arid places on Earth? Sometimes, when it rains. The rain falls hard here. Sweeping away almost everything in its path. And all that water disappears in a flash.
Was this place filled with a lot of water at some point?
It wasn't a lot of water, but every so often you get a rain storm that floods the plains around here, and then the flood waters stream through these valleys, and then they form these muds that you see here that flake pretty easily.
It's quite a lot, actually. How long do you think the water stays here for?
Oh, probably a few days.
Hardly enough time for life to flourish. Can anything survive year-round in an extreme environment like this?
So we're just about to cross sea level here, and now we're descending down below sea level. There's not many spots on the Earth that are deep below sea level. This is one of the deepest. Off on the horizon, you can see some of the salt flats. So Death Valley is basically a big bathtub that has no drain.
And in this giant bathtub, there's a surprise. Oded and Sarah are not sure what they'll find.
It's very salty.
Yeah, I can see all the salts along the bank.
In fact, it's so salty that most life forms that we know can't live here. But there's some life that has adapted to these extreme conditions.
Like what?
And if you look at some of these algal mats, some of these, let's see if we can find the piece. So there's algae that grow here. These are algae that really like salt. They're called halobacteria.
The water in this creek does not come from rain. Instead, it seeps from beneath the ground, like it could on Mars or other rocky planets.
It's about 2.5%.
Let me check.
You can take a look.
Yes, it is, almost exactly. So what does that tell us about how salty the water actually is?
So ocean water can be up to a couple of percent in its salt content. At about 20%, salt just precipitates out and crystallizes. So this is well below saturation.
One tiny fish has not only adapted to a hellish environment, it's managed to outwit extinction. The Death Valley pupfish is the last surviving species from an ancient lakebed that dried up here during the Ice Age, leaving behind this harsh desert in its wake. If life can survive here, Sarah believes it can take hold anywhere. All it takes is liquid water, no matter how little.
Everywhere you look, there's life. In salty environments and dry environments, in acidic environments, life is in almost every single square kilometer of Earth, wherever there is water. One thing is for sure, that with exoplanets, anything is possible under the laws of physics and chemistry. So if there's salt here in this river, if there's salt here in this creek and life is here, you can bet that there's an exoplanet somewhere where all the watersheds are this salty and where there is abundant life.
But proving water exists on a planet trillions of miles away is a daunting challenge, far beyond the ability of Keck, Corot, and even Kepler. New tools, a new telescope, and an entirely new way of seeing the cosmos are all needed in the race to be first to find the next Earth. In secure, clean rooms all across the nation, the future is under construction.
As you can tell, it's a little bit noisy in here, and that's because this room needs to be kept very, very clean.
Teresa Segura is a lead scientist on the next generation in space exploration, the James Webb Space Telescope. Teams of scientists are hard at work on a marvel of engineering that will soon scour the universe for signs of life. James Webb will orbit the sun in tandem with our planet from a perch almost 1 million miles away. The telescope's precision optical system only works in the extreme cold of space, where it's some 400 degrees below zero. Solar heat can destroy Webb's delicate electronics. So a powerful new sun shield is in the final stages of testing. 5 layers of specially designed Kapton blankets work in concert to create the highest SPF in the galaxy.
The sun shield is protecting the Webb telescope from the sun, just as you put on sunscreen, except the equivalent of the sun shield is 1 million SPF, not the 50 that you're used to.
Unlike most other telescopes, Webb will search for the next Earth in an invisible part of the spectrum called the infrared. That's because viewing the universe in the infrared allows the telescope to peer through dusty clouds and see farther and more clearly into deep space than in the visible range.
The Webb telescope is the largest infrared telescope ever built, and it operates in the infrared because it's looking for very faint objects. You can think of infrared as heat. You can feel heat, but you can't actually see it with your eyes. Another good example is night vision goggles. You can't see at night, but when you put the goggles on, you can see things around you because the goggles function in the infrared.
But the Webb telescope is like night vision goggles on steroids.
Webb's ability to see faint light is so good that it would be able to see a night light on the moon from a spot on the Earth.
It is the most powerful infrared telescope ever designed. Transporting this collage of mirrors, Kapton, and electronics into space presents an enormous challenge.
It is actually wider than a two-story building is tall, and because of that does not fit in any current rockets. And so we had to segment it, and that is make it into 18 individual segments so that we could fold it up, sort of like origami, and fit it into the rocket. So we could consider it the origami telescope.
Once it is unfolded, this origami telescope will set its sights on finding water and the chemistry of life by analyzing the atmosphere of alien worlds.
James Webb can detect the key ingredients for life, that being carbon dioxide, carbon monoxide, methane, and water.
All in hopes of answering the question, are we alone? Perhaps leading to the ultimate prize.
Finding life on any planet besides the Earth would just be the discovery of a lifetime.
And that discovery will owe a lot to all that has come before. 2008, the venerable Hubble Space Telescope makes history. These are only a handful of pixels, but together, they are the first direct image of a planet captured around another star. The planet is 25 light years away in the southern constellation of Pisces Australis and is called Fomalhaut b. For astronomers, the day is coming when this handful of pixels is another Earth.
We're developing the technology right now to one day be able to take a picture of a planet.
And when they do, it will change our lives forever. It is perhaps one of the most famous photographs in the world. The Earth, as seen for the first time from space by the crew of Apollo 8.
I think that the first images of Earth from the Apollo missions changed the way that people thought of Earth. And when we find pale blue dots, other Earths far away, it'll just completely change the way that we see ourselves.
It's very different to actually know, to be able to look up in the sky, point to a star, and say, I know that there's living creatures right there, right there.
Humanity is on the verge of the greatest revelation in history. There may come a time when we can look at an evening star and see something familiar. An alien Earth with its own civilization looking right back at us.